Now, yesterday, I mean, in the last class, we stopped with unconcluded or inconcluded discussion about Monogovindo. Are you around? Here's Monogovindo, or what's his name? I forgot.
Monojit sir.
Monojit. Yeah, are you around? Yeah, you are Monojit, right? Monojit, are you around?
Yes sir.
Okay. Yeah. So actually, in the last class, we are discussing about the second law, and there in the statement it was written that the isolated system or closed system, right? Something was there in the statement of the law. Now, whole idea is actually Nandini is very right that when I'm going to talk about a system, actually here what I'm considering is the system itself. So this system is not interacting with the surrounding. So when I'm talking about the entropy increasing, that means the system is not interacting with outside. Whatever is happening in the system is in non-equilibrium state, and that system, when it is going to the equilibrium, then it is not, as it is not exchanging, from the thermodynamics, that if you exchange the heat, then somebody gives and somebody takes, and therefore someone is losing entropy and someone is gaining entropy, and therefore as a whole you look at the total entropy is increasing or decreasing, right? Now here we are considering only the system. That system is undergoing through some changes, and it is going towards the moving towards the equilibrium. So a system, when I'm saying, so it is better to retain that word, that isolated or closed system. I think it was a closed system, right? Can you
Yes
remember
sir.
the okay. So then what exactly we mean? We mean that that system itself, the whatever entropy is changing within the system, not outside, because it is not changing, it is not interacting with the outsider, and therefore it is not exchanging heat with the outside. So it may be two boxes. When we allow the two boxes to mix its gases with each other, then we consider the two box as a whole as a system. Okay, then we can talk about the entropy change of that system, because that system is not exchanging any kind of stuff with the surrounding. Okay, so that's the whole essence. Okay, so in that sense, it's better when we are talking about the entropy change, we are talking about only the particular system, and that system, of course, is not gaining something or losing something with the surrounding. Okay, so that's the essence actually. So now probably you understand, and Nandini also made it very clear that if it is interacting with the surrounding, then surrounding will have a change in entropy and the system will have, and therefore altogether we have to calculate both the entropy changes altogether. But here we are to make it very particular, we are saying that the system itself is not interacting with the surrounding. That means it is not exchanging anything, heat or whatever, with the outsider, and only whatever is happening in the configuration changes, that is happening within that system itself. In that sense, it is closed. Okay, so that's now very clear. Okay, next we are talking about the ensemble. Okay, so as I said that the what is ergodicity, and of course we have gone through the equal probability, and so on, that therefore what the basic idea was that if we let the system remain, and also at the same time I compared with the quantum system and the classical system. In the quantum system, in the same system, you cannot measure many times, because it will return the same value, because quantum postulate tells you that it will return you the same value once you have made the measurement. Okay, so you have once you have known about the system's state, then it will fix to that, it will lock to that state, and therefore if you measure n number of times in future in time, then it will return you the same value. And therefore here it is different, we are talking the classically, and here we are saying we can calculate the microstate in terms of the state of the system in the phase space. That is, you assign, when classically you treat with, you know that you solve the Hamilton's equations of motion, and therefore you calculate with time, its position, its momentum, and therefore you describe the particle or the system in terms of or the particles or as a whole the system in terms of its momentum and position coordinates at different time. And therefore as it moves, as time evolves, then the system will move through pass through different coordinates of momentum and position, and therefore it will try to visit different kinds of microstates, because a microstate is nothing but a collection of if you have n particles, you have n 3n degrees of freedom for the spatial coordinate and 3n degrees of freedom for the momentum coordinate, and therefore as a whole 6n degrees of freedom, 6n variables you are dealing with respect to time, and each 6n probably, I'm not sure at this moment, it will be revealed afterwards. Maybe those 6n coordinates will specify the status of the system and hence the microstate of the system. So that is the whole essence. And in the meantime, if you have any problem in understanding, you can just eventually you can stop me and you can ask a question. Because you more you discuss, it becomes more clear. Okay, and this is the process of learning for both teacher and student. Now, how about considering a fixed instant of time? So instead of that, that is what we discussed in the last class also, that instead of taking time averages, rather than waiting for long time, you can, since it will pass through each microstates with time, then you can have an ensemble of these systems, and each system has the probability to be in any of the allowed microstates, and therefore it would be probably better to have a large number of systems, all being the replica of the original system, but they are in all different kinds of possible microstates. Thus, all that we want to convey is that instead of taking the time average, which is essentially an average over various microstates, we can fix the time and take the average of the desired function, whatever you want to calculate, position, momentum, whatever, energy, whatever you want to calculate, which is physical, measurable, and so on, over a large number of replicas. That is what is called ensemble. Ensemble is a collection of systems actually, and these two averages do serve the same purpose, as I said, and also you can visualize that they will serve the same purpose. Therefore, we can adopt the average over the ensemble, large number of identical systems with equal probability of being in any microstate. Thus, we develop the ensemble theory. Okay, that is what we stopped here in the last class. Now, for classical system, the most appropriate workshop, for developing the theoretical formalism is the phase space. I already talked about the phase space, because when you are talking about the six coordinates, 3n real spatial coordinate and 3n momentum coordinates, and eventually you're talking about a point in a phase space of 6 dimensions. So you have to deal with the phase space. Phase space of a classical system, think of the system classically. The microstate of a given classical system at any time can be defined by specifying the instantaneous positions and momentum. All momenta is this one plural of all the particles of the system, as I said, as mentioned earlier, and there is no harm in repeating things which are very important. Okay, if the system consists of n particles, they will have n 3n position coordinates, as I said, and 3n momentum coordinates, as I said earlier. Altogether 6n coordinates, and therefore 6n dimensional space. The space that is called the phase space. Okay, and therefore the set of coordinates q1, q2 up to qn, p1, p2 up to pn will represent a point in the phase space, which in turn represent a microstate, which may be referred to as a representative point. You can name or refer this as a representative point. And all these languages are taken from the FACTIA, which is, I think, in my opinion, to the best of my knowledge, is the best book so far for these chapters. Now, this representative point, have any of you gone through the book by Avijit Lahiri? Any of you have gone through the book by Abhijit Lahiri. The book is something called, what is the title of the book? Is there anybody? Have you seen that book by Abhijit Lahiri? Anyone? কেউ দেখোনি বইটা? হ্যালো হ্যালো, শুনতে পাচ্ছ তোমরা?
হ্যাঁ শুনতে পাচ্ছি কিন্তু দেখিনি বইটা।
ও তাই বলো না, দেখিনি। এটা রিপ্লাই দাও, যা হোক যে হোক। এনিওয়ে, দেখতে পারো বইটা, বাট আমার মনে হয় যে ওই বই পড়ে যতটা না বোঝা যায় তার থেকে প্যাচিয়া পড়ে আরো বেশি বোঝা যায় আর কি। যদিও সেটা আচ্ছা, এনিওয়ে, নাও and which book you have actually with you? তোমরা একটা বই তো জোগাড় করেছো নিশ্চয়ই, কোনো না কোনো বই। কি বই তোমাদের কাছে আছে?
পাত্রিয়ার ইটা আছে, যে পিডিএফটা আছে, আর এমনি বই হিসাবে একটা বিবি লাউড বলে বইটা বিএসসি টাইমে নিয়েছিলাম, ওটা আছে।
বিবি লাউড?
হ্যাঁ।
ও আচ্ছা আচ্ছা আচ্ছা, না আমি দেখিনি, বিবি লাউডের বইটা দেখিনি। দেখিনি। কেমন বইটা?
আমি ওটা বেশি পড়িনি, প্রথম দিকেই পড়েছিলাম।
আচ্ছা, ওকে। অ্যান্ড বিএসসিতে এরা কোন বই ফলো করেছিল? যারা ক্যালকাটা ইউনিভার্সিটি থেকে পড়েছে, ক্যালকাটা ইউনিভার্সিটি যারা পড়েছে তারা?
স্যার আমরা সত্যপ্রকাশ, স্ট্যাটিস্টিক্যাল মেকানিক্স।
আচ্ছা আচ্ছা, okay, all right. So those are the representative points. Okay, one point, allowed point for the system in the phase space called the representative point. You can refer it as a representative point in the phase space, which in turn represent a microstate, which may be referred to as representation point. Now this representative point is changing, as I said, with time, as Q's and PI's are governed by the following canonical equation. These are the familiar equation, right? I think Sikantoda has talked a lot about these equations, where your H Hamiltonian is basically function of all these, is the Hamiltonian of the system. Now, as time passes, the set of coordinates Qy, Pi, which also defines the microstate of the system, undergoes a continual change. আমি অবশ্য বলে দিয়েছি এগুলো, এগুলি আবার ভাষাতে লেখা আছে, undergoes a continual change. So you may feel that the representative point in the phase space will curve out a trajectory whose direction at any time t is determined by its velocity. Velocity means both q dot and p dot. Now it is also clear that the trajectory will be confined to a limited region, because your volume is fixed, v is fixed, and also the energy has a limited interval, okay, or maybe fixed, or it has a little width, and therefore your phase space that you are you were concerned about, it is a limited phase space, because you cannot have an infinite volume. V is maybe large, but you have a finite volume, right? You have a volume V, you cannot go beyond that. So all these QIs should be confined within this V, and also PIs would be such that your energy, both actually Q and P, once you fix Q, then
Yes.
P would be yeah,
স্যার ওই ভলিউমটা তো ফিজিক্যাল ভলিউম,
physical volume, yes.
কিন্তু কিউআই পিওয়াই ওটা তো ম্যাথামেটিক্যাল টার্ম না।
QI, these are your coordinates and momentum. QI and PI. কে বলছো? নামটা বলো।
অর্ঘ স্যার।
অর্ঘ, ইয়া। হ্যাঁ বলো, তোমার কোয়েশ্চেনটা একটু ভালো করে বলো।
আমি বলছি ওটা তো ম্যাথামেটিক্যালি আমি ওটা ক্যালকুলেশনের সুবিধার জন্য কিউআই পি তে ট্রান্সফর্ম করেছি, তাহলে ওখানে কি ওইরকম ভি ভলিউমের লিমিট ওরকম বলা যাবে?
ভি ভলিউমে,
ভি ভলিউমটা তো মানে ফিজিক্যাল ভলিউম, থ্রি ডাইমেনশনাল
ক্যাপিটাল
ভলিউম।
ভিটা তো, ক্যাপিটাল ভিটা তো,
হ্যাঁ,
হ্যাঁ,
থ্রি ডাইমেনশনাল স্পেসে ভলিউম তো ভি ভলিউমটা।
না না, তোমার okay, if it is in three dimension, of course particles are in three dimension. If you have n dimension, v is the physical volume. You are right. Three dimension, right? Yeah. V is physical volume, right? So
না, আমি বলছি কিউআই পিআই ওটা যে 6n ডাইমেনশনাল হাইপার স্পেস, ওটাকে কি ভি ভলিউম দ্বারা ওটা মানে কিভাবে কনস্ট্যান্ট থাকবে?
না 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 না, তুমি হাইপার স্পেসের কথাটা তুমি এখন আনছো কেন? হাইপার স্পেস তো বটেই, হ্যাঁ, সেটা তার ম্যাথামেটিক্যাল কনস্ট্রাকশন, হ্যাঁ, হাইপার স্পেসটা। কিন্তু তুমি ধরো এটাতে প্রবলেম কি আছে, এখানে যদি তোমার এনটা পার্টিকেল থাকে, ফার্স্ট পার্টিকেল আই দেওয়া আছে, দেখো এই আই ইজ রানিং ফ্রম 1 to n, ওকে। সো তোমার প্রথম যদি পার্টিকেলটা আইটা 1 হয়, তাহলে তার জন্য Q1 Q2 Q3 তো থাকবে একটা পার্টিকেলের জন্য, অন্য পার্টিকেলের জন্য অন্য Q1 Q2 Q3 থাকবে, অন্য পার্টিকেলের জন্য অন্য থাকবে, রাইট? তো সেটাই হচ্ছে কিউআই দিয়ে তুমি ডিনোট করেছো। ফার্স্ট পার্টিকেলের জন্য তুমি ধরো একটাতে তিনটে পার্টিকেল আছে, ধরো তোমার একটাতে আছে x1 y1 z1, অন্যটা x2 y2 z2, তারপরেটা x3 y3 z3। তার মানে তোমার xi কত হলো 1 2 3, x1 x2 x3, y-টার জন্য y1 y2 y3, তাহলে আর z-টার জন্য z1 z2 3, তার মানে তোমার 9টা কোঅর্ডিনেট চলে এলো, তাই না? সেইটাই তুমি ওই যে 1 to 9, হ্যাঁ, তুমি এটাকে কিউআই হিসাবে লিখছো। তোমার x1 x2 x3 y1 y2 y3 z1 z2 z3 এর মধ্যে থাকলো তিনটে পার্টিকেলের জন্য, তাহলে আই উইল বি রানিং ফ্রম 1 to 9। আর তুমি হাইপার স্পেস ভলিউম যেটা বলছো সেটা তো অন্য ভলিউম, সেটা তো একটা ম্যাথমেটিক্যাল কনস্ট্রাক্ট, সেটা অন্য ভলিউম, বাট দিস ইজ আ ফিজিক্যাল ভলিউম। সেই ফিজিক্যাল ভলিউমের মধ্যে এইগুলো ওদের কোঅর্ডিনেট, বিভিন্ন পার্টিকেলের কোঅর্ডিনেট গুলো বিভিন্ন হবে। এক পার্টিকেল গুলো বিভিন্ন জায়গায় থাকবে, এক এক জায়গায় তাদের এক এক ধরনের কোঅর্ডিনেট হবে, এক্স ওয়াই জেড এক এক রকম হবে।
ওকে স্যার।
কোনো কনফিউশন নেই তো? না, কনফিউশন স্টিল রিমেন্স?
না স্যার।
ওকে, ঠিক আছে, হ্যাঁ, প্রশ্ন করো মাঝে মধ্যে, যেখানেই প্রবলেম হবে, যেখানেই বুঝতে পারছো প্রশ্ন করো, হ্যাঁ। আচ্ছা, so this is the volume, as Orgo said, this is the physical volume, three-dimensional volume that we visualize, and this is, so v is fixed। তার মানে তোমার পার্টিকেল গুলোর যে কোঅর্ডিনেট এই যে এগুলো হবে, এগুলো সবটাই v এর মধ্যে থাকবে। আবার এইটাও তোমার এনার্জি দিয়ে, এবার এনার্জি h তুমি জানো, you can write h in terms of q and p, and therefore your h is limited, কারণ তুমি মাইক্রো মানে এতে আর কি, মানে যখন মাইক্রোস্টা ডিফাইন করছো তখন তুমি ইটাকে ফিক্স করেছিলে at least or at most what you did, you gave a window to the energy। তার মানে এনার্জি যদি উইন্ডো থাকে তাহলে তোমার পিটা লিমিটেড হয়ে যাবে, therefore your phase space will be limited, okay, in such practical situations। So basically your trajectories, what I'm saying, that your trajectories that will have, it will not be extended to anywhere, right? It will be confined to a phase space, because you have limitation on the position, because it is fixed by volume, and also limitation on this because of your both q and energy. In particular, if the system is known to have a precise value of v, the corresponding trajectory in the phase space will be restricted by the hypersurface। That means যদি তোমার ফিক্সড ই হয়, তাই না, তার মানে যে হাইপার সারফেস হয়, তার মানে তোমার সমস্ত কিছু রেস্ট্রিক্টেড থাকবে অন দ্য সারফেস। যদি ইটা কনস্ট্যান্ট হয় অন দ্য সারফেস, এটা আমরা আগেও পড়েছি, অন দ্য সারফেস অফ দ্যাট হাইপারস্ফিয়ার। আর হাইপারস্ফিয়ারটা কি হচ্ছে, দিস ইজ এ কনস্ট্রাক্ট, ইন আ সেন্স we are assigning all the qi and pi values to these coordinates, okay। And more realistically, as I said, if the energy lie in the range, say e minus half delta, as I said, at most you can give some width to that, and we have already experienced earlier that that doesn't matter much as far as microstate and physical quantities are concerned, and corresponding thermodynamical quantities are concerned. Then the corresponding trajectory will, if you have this e has a width of delta, that means e is ranging from e minus half delta to e plus half delta, the corresponding trajectory will be restricted to the hypershell defined by the limits. Now consider an ensemble of systems which may be represented by a large number of representative points in the phase space. As we discussed earlier, the representative points change with time, and therefore the representative points constitute a swarm continually move along their trajectory. Swarm কথাটা জানো? তোমরা পড়েছো ছোটবেলায় বোধহয়। What this swarm means is SWARM. রূপক?
হ্যাঁ স্যার,
swarm মানে কি?
দেখতে হবে স্যার।
এ বাইকের আওয়াজ হচ্ছে কেন?
স্যার ফ্যানের স্যার।
ফ্যানের?
হ্যাঁ স্যার।
swarm
টেবিল ফ্যান চলছে।
হ্যাঁ?
স্যার টেবিল ফ্যান চলছে
হ্যাঁ।
ওই জন্য।
ও swarm মানে
মৌমাছির ঝাঁক বোঝাতে তো স্যার বোঝে না।
কে বললে?
মৌচাক বলে তো আমরা।
না কে বললে একজন মৌমাছি ঝাঁক বোঝা নয়, কে বললে?
স্যার প্রীতম।
হ্যাঁ ঠিক ঠিক আছে। এবার বন্ধু খুব ঠক ঠক করে আওয়াজ হচ্ছে কোথায় একটা, যাকে ঠিকই বলেছো, মানে এক ঝাঁক আর কি, এখানে এক ঝাঁকই বোঝানো হচ্ছে, কালেকশন অফ রিপ্রেজেন্টেটিভ পয়েন্টস। ওকে, so in that analogy, okay, so the representative points change with time, and therefore the representative points constituting the swarm মানে একটা ঝাঁক আর কি, continually move along their trajectories. বুঝতেই পারছো, তুমি যখন একটা ensemble নিলে তখন এক একটা ensemble তুমি ধরছো যে এক একটা মাইক্রোস্টেটে আছে, of course that should be at par with the macro state. Okay, that means inconsistent with the macro state. তার মানে প্রত্যেকটা সিস্টেম, ensemble it's a collection of systems, প্রত্যেকটা সিস্টেমের এক একটা মাইক্রো স্টেট থাকবে এবং দ্যাট ইজ রিপ্রেজেন্টেড বাই আ রিপ্রেজেন্টেটিভ পয়েন্ট। এবার অতগুলো একসঙ্গে আর কি, দে উইল বি মুভিং অ্যালং দ্য ট্রাজেক্টরিজ ইন দ্য অ্যালাউড ফেজ স্পেস রিজন। ওকে, কারণ ও বাইরে যাবে না, কারণ তোমার পি এবং কিউ দ্যাট ইজ রেস্ট্রিক্টেড বিকজ অফ ইয়োর ভলিউম অ্যান্ড এনার্জি। নাও what is saying, so you now you have a feel that in the phase space there are a collection of these representative points. Then it's better to deal with them, it is better to introduce something what is called density function, this rho p q t at time t, which may take care of the distribution of representative points in the phase space. So this is the density of representative points in the phase space. Okay, so we introduce a quantity rho which is function of qpt, and this is called the density of representative points in the phase space. Okay, now so this rho will represent the density of representative points in the unit volume in the phase space around the point qp. Of course, I mean, when I'm talking about the density at some point, that means the density means the number of points around that region per unit volume. Okay, so in this case it is the number of representative points that you have in the phase space per unit phase space volume, but around the particular value q and p at time t. Or as you know, in probability you know better because you have already gone through quantum mechanics probably, that rho qpt is a density, and then you multiply a little elementary phase space volume, then you would say that this indicates the number of representative points in the phase space volume this around the point this. You have a point in the phase space, and around that you have an elementary volume of this d3 and q, d3 and p. In that volume, that number of representative points should be if you multiply by rho. So this will be the number of representative points in the phase space in the volume this around this point q and p in the phase space. Therefore, if you have got the density of these representative points in the phase space, then obviously you can have the average, ensemble average in this way, because this is the density of representative points, and therefore any quantity which may function of Q and P, if you wish to calculate the average, ensemble average, then obviously you use this rho, right? This is the as you calculate in terms of the probability density and so on. So this is the function you want to have the average value of this, and this is the density of phase space points, and this is the elementary volume, integrate over, and then total number of phase space points that you have, integrate over. And this integration would be, of course, in the restricted region that you have depending on your E and V and delta. So note that integration in 2 extends over, আমি যেটা বললাম সেটাই লেখা আছে, note the integration in 2 extends over the entire region of the phase space. However, only contribution comes from the region where rho is non-zero, because other than the what it means, what it's saying here is this is of course over the entire phase space, but eventually it will be contributing only from that area of the phase space where the density of states is non-zero. That means it is only finite or non-zero in the allowed region of phase space, depending on your physical volume and the energy, allowed energy range. Okay, so that is what has been written or documented. হ্যাঁ,
একবার বুঝলাম না, আরেকবার বলুন।
আচ্ছা, কে বলছো, নামটা বলো।
অর্ঘ্য।
অর্ঘ্য। এইটার মানে হচ্ছে, now you are going to the ensemble average, right? If you want to have the ensemble average, then you have to know the ensemble density also, right? So rho is the ensemble density. Okay, and each member in the ensemble is represented by a microstep, and that corresponds to a point in the phase space. Okay, so and this is the density that we are denoting this as the density of those representative points, which corresponds to each representative point corresponds to a member in the ensemble. Okay, because ensemble is a collective collection of your identical systems. Okay, replica of the systems. Now if you want to have the average of this over the ensemble, then of course you have to have the density of ensembles with those PQ values, and then integrate over the entire phase space divided by total number of representative points you have. That means the integration over the entire phase space on this. Now the point is that what I'm saying, that this integration actually is done only on the allowed phase space, not the entire phase space, because you can do for the entire phase space for your convenience in the calculation, but the contribution will come only from those regions of the phase space which are really allowed. The systems are allowed. If systems are not allowed, then rho would be zero, right? Only rho,
E থেকে E plus delta এর মধ্যে যে phase space টা ওইটা।
exactly. And beyond that, because the system is not allowed to explore any microstate outside that, right? Any state outside that, and therefore the density of representative points would be zero, above that region, okay, outside that region. So only that spherical cell, you are right, exactly, only on that spherical cell that you have, because that is the cell, that is the space area that is allowed by restricting the energy, and therefore you would have finite rho, and therefore that integration will be actually extended over that allowed phase space area, even though mathematically you can extend it up to infinity. Okay, because on the other part of the cell you have rho zero. That is what it is saying, that the integration into extends over the entire region of the phase space. However, only contribution comes from the region where rho is non-zero. We further note that as rho itself is a function of time explicitly, the average f will also be a function of time. অর্ঘ্য, বোঝা গেল?
মানে রোটা কি টাইমের সাথে চেঞ্জ করবে E থেকে E plus delta এর মধ্যে?
আমরা এক্সপ্লিসিট টাইম ডিপেন্ডেন্সটা যতক্ষণ ধরছি ততক্ষণ চেঞ্জ করবে। আমরা যদি অন্য স্টেটে চলে যাই, আমরা যেটা নিয়ে ইন্টারেস্টেড থাকি সেটা নিয়ে আমরা দেখবো সেখানে কি হয় না হয়। আপাতত উই আর কিপিং ইট মোর জেনারেল। রো ইজ ফাংশন অফ পি, কিউ, পি and explicitly function of t. Okay, for the time being we are keeping it more general. আর তোমার ইন্টিগ্রেশনের ব্যাপারটা, লিমিটের ব্যাপারটা ঠিক হয়েছে?
ইন্টিগ্রেশনে হ্যাঁ, লিমিট দেওয়া নেই তো।
না, লিমিটটা কোথা থেকে কোথায় হবে সেটা বুঝতে পারছো?
হ্যাঁ হ্যাঁ, ওটা ঠিক আছে।
ওকে,
মানে আমি যেটা বলতে চাইছি, ই থেকে ই প্লাস ডেল্টা এর মধ্যে রোটা কি কনস্ট্যান্ট হবে না? মানে অল মাইক্রোস্টেট ইকুয়ালি প্রবাবল হয়,
কি করে বলবো?
অল মাইক্রোস্টেটস যদি ইকুয়ালি প্রবাবল হয়,
অল মাইক্রোস্টেটস ইকুয়ালি প্রবাবল হয় যদি রো যদি তোমার ফাংশন অফ টাইম হয়, এখন কি করে বলবো তুমি এই করে?
এক একটা রিপ্রেজেন্টেটিভ পয়েন্ট তো এক একটা মাইক্রোস্টেটকে রিপ্রেজেন্ট করবে।
করছে,
তাহলে
সবাইকে করবে, রিপ্রেজেন্ট করবে, সব কটার মধ্যে দিয়ে যাবে, কিন্তু আমি রোটাকে কনস্ট্যান্ট বলবো কি করে এখনই? তোমার বেসিক্যালি ইকুয়ালি প্রবাবল মানে ও সবার মধ্যে দিয়ে সব কটাকে এক্সপ্লোর করবে। Over the time it will explode everything. Okay, now how can I say that rho will remain constant in the beginning? মানে দেখো অর্ঘ, তোমাকে একটা কথা বলি, তুমি যদি কিছুটা পড়ে থাকো সেইটাকে তুমি আগে এক্সপ্রেস করো না, আমি আমি যে পর্যন্ত যাচ্ছি সেইখানে এক্সপ্রেস করো। তুমি এমন হতে পারে, I know this is the kind of practice of the students where somewhere you have heard that rho will remain constant, and now without having any, of course you have a logic, you said, but that doesn't guarantee that rho would be constant. Okay, তুমি আগে পড়ে থাকলে সেটাকে যদি তুমি এখানে ইম্পোজ করো, আর কি কেউ হয়তো বলেছেন যে রোটা কনস্ট্যান্ট হবে, সেটাকে তুমি এই মুহূর্তে ইম্পোজ করলে I have problem to accept that, because I do not find any logic to make rho constant at this juncture.
ওকে,
তুমি বুঝতে পারলে?
হ্যাঁ স্যার।
কারণ এখানে তুমি রোটাকে কনস্ট্যান্ট করবে না, তোমার যে কনসার্নটা, your concern is you keep on asking, okay, I am liking you keep on asking, কথাটা হচ্ছে যে তুমি যেটা বলছো যে ইকুয়াল অ্যাপ্রারি প্রবাবিলিটি মানে সবকটাকে এক্সপ্লোর করবে, সবকটা ইকুয়ালি এক্সপ্লোর করবে, ঠিক আছে, হ্যাঁ, কিন্তু আমার কোনো জায়গায় বেশি এক্সপ্লোর করে ফেললো, কোনো জায়গায় কম এক্সপ্লোর করে ফেললো, তো আমি তো জানি না কে কখন এক্সপ্লোর করবে, সুতরাং আমি ডেনসিটিটা কনস্ট্যান্ট কি করে বলবো? আমি বলতে পারি অ্যাজ এ হোল, ইট হ্যাজ এক্সপ্লোর্ড অল দ্য this one equally probably, but how can I say that rho is constant? And with time also, I mean, it is also changing with time, right? Because we have taken the explicit time dependence, as your Hamilton's equation says, things will be changing with time, right? ঠিক আছে অর্ঘ? আচ্ছা, আর একটা তোমাদের কথা বলি, ধরো আজকে একটা ডিসকাশন হলো, হ্যাঁ, ডিসকাশন সবসময় কোনো সময় কখনো ফিনিশ হয়ে যায় না, হ্যাঁ, সাপোজ উই আর ডিসকাসিং and then you go and rethink, and if you think that I have my logic that I have given or my understanding is not matching with your understanding, the next time come to the class and ask me the question, okay, that this is my understanding, your understanding, my understanding is not matching with this, and then we can discuss. Okay, so keep that discussion on. All right, Argo?
ওকে স্যার।
Okay, all right. Okay, so that is what it. Now we come to, as Orko said, actually eventually we'll be moving towards that, but till this one I did not have any logic to make rho constant. Okay, so let us see. Now, an ensemble is said to be stationary if rho does not depend explicitly on time. Okay, so now we are thinking the situation will be dealing with the stationary state situation. Okay, so we will be doing equilibrium statistical mechanics, not non-equilibrium statistical mechanics. Okay, and therefore we are assuming that the rho will not have a explicit time dependence, and therefore del rho del t is 0. Okay, with the condition depicted in equation 3, that means this, that is for stationary ensemble, the f average will now be independent of time. Let us look at it in greater detail, under which the circumstances of equation 3 holds good. Okay, now look at it. So del rho del t is 0, okay, because we are dealing with a stationary state situation. Now consider an arbitrary volume. This is the arbitrary volume in the phase space, okay, omega, as I have shown here. And now the rate at which the number of representative points increase is given by the number of points increased, is given by del t of rho dv, because rho d omega you integrate over omega will give you total number of representative points. And now the rate of increase, of course, will be del t of this, right? Now, on the other hand, the outgoing flux should be rho v. V is the velocity. These representative points are moving, so rho v dot d omega, because your the flux, basically the flux calculation you know very well. If there is a vector A and there is a surface area ds, then A dot ds is the flux through that surface, and then if you integrate over, you get the total flux of this closed surface, okay, in the phase space. Now okay, so then you can just use that vector identity, that is rho v dot d omega, that you can write it as divergence of this d omega, right? And that is for bolo.
বলছি মানে ফ্লাক্সটা ওটা কেন হলো আরেকবার বলুন তো, রো ভি ডি এটা।
These are the representative points. As I said, as the time is evolving, your q and p are changing with time, and therefore you will have a corresponding velocity of those representative points, okay? So one representative point in the phase space, it's a 6n-dimensional phase space. One representative point indicates 3n degrees of freedom, and as far as your position is concerned, and 3n degrees of freedom as far as momentum is concerned. Total 6n degrees, and 6n coordinates in the phase space, and each point corresponds to a representative point or a microstate. Now these points in the phase space are changing its position, right? So it is moving on the phase space, okay? And therefore you have to have the how much, if you talk about this capsule, then you know how much flux it would be, right? Your vdt is the length and so on, and therefore the flux per unit time, that would be your divergence of this dot ds. If your quantity is some vector a and the surface area is ds, you know the flux is a dot ds, right? So this is rho v. This is the in unit time, this amount of points are moving right towards the surface. And now the projection, now we have to see, dot means how much is perpendicularly crossing the surface area, right? So you have to take the perpendicular cross section of the perpendicular projection of the area, right? So this is what is the flux. This is a vector a, say for example, and since representative points are moving, so it will be related to the velocity. And if you see the velocity in unit time, v times the cross sectional area, that much will pass through, right? And that is what is the flux of the representative points. মৌসুমী, কে জিজ্ঞাসা করলে? মৌসুমী, হ্যালো হ্যালো, শুনতে পাচ্ছ?
হ্যাঁ স্যার, মৌসুমী জিজ্ঞাসা করছে।
ও হ্যাঁ, না মৌসুমীর আওয়াজ পাচ্ছে না তো।
হ্যাঁ স্যার, বলছি তখন হয়ে গেছিল নেটওয়ার্ক কানেকশন।
বুঝতে পারলে? শুনতে পারলে?
হ্যাঁ শুনতে পেয়েছি।
বুঝতে পেরেছো? Okay. So this is the flux, and then you use the divergence theorem. I don't know the Stokes theorem, divergence theorem, whatever theorem it is, that surface integral to volume integral. এটা কি বলে, কি theorem বলে? আমি ভুলে গেছি। Surface integral কে volume integral, divergence. Okay. All right. So this is that you get the divergence and then d omega. Okay. Now this is 1 and 5. No. All right. So this is what it is, and then your divergence of rho. এটা ঠিক আছে? একবার দেখে নাও ইকুয়েশন 6 টা। Okay, now considering the conservation of representative points in the phase space, তার মানে আমি যেটা বলতে চাইছি কোনো মানে রিপ্রেজেন্টেটিভ পয়েন্টস ওখানে কোনো সোর্স নেই, কোনো সিঙ্ক নেই, কেউ রিপ্রেজেন্টেটিভ পয়েন্টকে খেয়েও নিচ্ছে না, কিছুই করছে না, তোমার নাম্বার অফ রিপ্রেজেন্টেটিভ পয়েন্টস রিমেন দ্য সেম, number of total microstates corresponding to macrostate will remain the same, right? And therefore we have this. So flux net outgoing is basically the decrease, net decrease of rate of decrease of this representative points equals to the flux of the representative points. Okay, so তাহলে তোমার এই দুটো ইকুয়াল হতে হবে, এই দুটো ইকুয়াল হলে তুমি একটা, এটা তোমরা দেখেছো কন্টিনিউটি ইকুয়েশনের মতো, তাই তো? দিস ইজ ট্রু ফর কন্টিনিউটি ইকুয়েশন এখানে আসছে, হ্যাঁ, তাহলে এই জিনিসটা ঠিক আছে, ফ্লাক্সের সঙ্গে এটার রিলেশন থাকবে, হ্যাঁ, তোমার কতটা বেরোচ্ছে তার সঙ্গে তোমার ডিক্রিজ কতটা হচ্ছে সেটার সঙ্গে রিলেশনটা থাকবে, দ্যাট হ্যাজ টু বি কনজার্ভড, রাইট? বিকজ ইউ আর নট ক্রিয়েটিং অর ডিস্ট্রয়িং রিপ্রেজেন্টেটিভ পয়েন্টস, and therefore it has to be conserved, and therefore you have to have the net outgoing flux equals to net decrease in the representative points per unit time in the volume that you are talking about. Okay, and this is true for any arbitrary volume. Okay, this is true for any arbitrary volume, right? And therefore this within the integral, this part should be equals to 0. So this is true for any arbitrary volume omega, and hence the integrand must vanish, and therefore you obtain this relation, del rho del t plus divergence of rho v equals to 0. And if you write this explicitly, then it will be del rho del t plus I 1 to n del rho del qi dot by del rho del pi dot plus rho times 1 to 3n del qi dot del qi plus del pi dot del pi, and that should be equals to 0. Okay, now this is your equation. Now exploiting Hamilton's equation of motion, now let us use the Hamilton's equation of motion in these things. Okay, আর এইগুলো তোমরা নিজের হাতে একটু করবে, হ্যাঁ, নোটটা দেখে দেখে, নাথিং ভেরি, there is not much difficulty, but একবার নিজে করবে, exploiting the Hamilton's equation motion, qi dot তোমরা এটা জানো, qi dot is del h del pi, and pi dot is minus del h del qi, and therefore you substitute them, and then eventually you get this equals to this equals to 0. Okay, so this y it want to then del qi dot qi del pi dot del pi, এই টার্মটা 0 হয়ে যাচ্ছে, del qi dot del qi del pi dot del pi, এই টার্মটা 0 হচ্ছে, তার কারণ হ্যামিল্টনস ইকুয়েশনে qi ডটটা বসিয়ে দাও, pi ডটটা এখানে বসিয়ে দাও, একটা মাইনাস সাইন আসছে, এবং দুটোই del 2h del qi del pi হচ্ছে, এরা ইন্ডিপেন্ডেন্ট, and therefore you get equals to 0. Okay, now therefore this equation reduces to only this term and this term, so eventually you will have del rho del t plus del rho del qi dot plus del rho del pi dot equals to 0, del rho, and then again you can put Hamilton's equation of motions, qi dot equals to del h del pi dot is minus del h del qi, so you put this and get this equation. Now if you proceed further, then the same equation I have written here. ওহো, এখানেরটা খুব বাজে স্ক্যান হয়েছে গো, পরে আমি এটাকে ইয়ে করে পাঠিয়ে দেবো, নাহলে তোমরা পাচ্ছেও দেখে নিতে পারো, পাচ্ছে। So del rho del t plus this equals to 0, and del rho del t equals to now, yeah, so del rho del t and this equals to 0, so you get this equation, right? Now if you write d rho dt, now rho is function of q pt, then you can write del rho del t plus, you know how to do it, del rho del qi dot, but del rho del pi dot, and sum over all i's, and then this is del rho del t, and then if you bring them together, then this is like this, and eventually d rho dt equals to del rho del t plus this, and this is equals to 0, right? Because your from the continuity equation you have this, right? d rho dt plus this equals to 0. You already have that, right? This one you already have. So basically d rho dt is nothing but d rho dt is 0. So now you can say rho is constant. Okay. Now rho is constant. Yes, rho is a constant. Okay, fine. Now let us look at the situation. So, and therefore you can write d rho dt, and this is nothing but the Poisson vector. In classical mechanics, you know, and in quantum mechanics it is kind of commutator. So this is 0. So this is a well-known equation. I think you have come across earlier also. This is called Liouville's equation. Okay, so it's a name given Liouville, so Liouville's equation. But the equation is this, which talks about the variation of rho with respect to time, and that turns out to be this, and that becomes 0. Okay, so rho is a constant. Now if this is 0, then this also has to be 0. Okay, so this is one thing you must note, that this also has to be 0. Okay, now so the change of rho, though basically this equation tells me, just look at this equation. Don't take this equation as if it is very known and very familiar equation and so on. Just look at this equation very carefully and see what kind of situations may arise. Okay, what kind of situations we can talk about from this relation. It is not just a mere Liouville equation, as you say. Of course it's Liouville equation, but it should not be treated lightly, as you have seen it earlier many times. Okay, now we are talking this in the context of the density of representative points in the phase space, and we find that the rho is not changing with time. The density of representative points are not changing with time, and it is constant with time. So that's the message. And now how can it arise? Or this might lead to various situations. What are the situations? Now see, this part came from where? This part came from the flux, right? And this is the rate of change of the representative points per unit volume, and this came from the flux through the surface, enclosed surface of a phase space volume. So there could be two situations. Okay, now let me see what they are saying, and then I'll come to that. This tells us that the total density of representative points as viewed by an observer moving with the representative points stays constant in time. Thus the swarm of representative points moves in the phase space in the same manner as an incompressible fluid moves in a physical space. Okay, this is kind of analogy that it has given. Okay, yeah. So now again I repeat the same thing here, that d rho dt is 0. Okay, d rho dt is 0. Now that, and also since there is no source, no sink, and that condition leads to this, and if we talk about the stationary situation, then this is 0, and therefore this also 0, but this comes from the flux. Okay, now now can you think of situations where del rho del t is 0? Okay, now can you think of situations where this d rho dt is 0, means rho is not changing with time? You are at some point in the phase space, but the density of phase space around that point is not changing with time. how can you achieve that? Can anyone tell me how can you achieve that? Acha. I mean, be at home with this kind of thought. Just think about this equation. Think about this equation and try to think about the situations which may lead to the rho constant with time. Okay, density of representative points constant with time. What are the situations?
N tends to infinite, V tends to infinite.
You think about it. I'm giving you time. I have a meeting at the department right now. I'll probably quit. Otherwise, I would have continued the discussion because it's so interesting, and you might have many opinions, as Orgo probably said. But I today I will quit. But think about it, okay? And in the next class we'll meet and discuss, okay? And also keep your questions ready for next class, okay? So I'm just quitting because I have a meeting at 6:30 at the department. All right.
Okay, sir.
Okay.